Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings, all you vintage audio hound dogs and pretty kitties. This is Retro Ernest of Retro Electrotech and the Retro Ernest Rock Show. Today on the bench is this Pioneer Model 1010 stereo receiver from around the mid-70s, and for all you specification junkies and audio monkeys, this heavy hitter comes stepping into the ring, bobbing and weaving and landing its blows at 100 watts per channel into 8 ohms to rattle your bones. And if that doesn't draw cheers from the crowd, how about a frequency response range of 10 Hz to 40 kilohertz? Oh yeah, babies. Now I see the sweat beads streaming while you're drooling and a-dreaming. Now for that THD that'll set you free. I see that figure coming in over the wire at 0.1%. So tip your hats to that, you groovy cats. Now let's stop all the grinning so we can get the platter spinning. Let's drop the needle on the vinyl because the vinyl is final. And never mind those crackles and pops. We don't need no stinking audio cops. Okay, so there's a little bit of my DJ persona. I am a DJ at a local radio station. I do a retro rock show. I'm taking some time off the air though because of my busy schedule, but I'm going to be jumping back on the air shortly. So I just thought I'd mention that just for kicks. But anyways, why was this nice Pioneer receiver brought in? Well, this unit was brought in with a customer complaint that there was a noisy, distorted, diminished right channel, and he also stated that there was some relay work performed on this receiver a handful of years ago. He wasn't sure whether there was relay replacement, whether they just cleaned the contacts and left the original relays in place. I really don't know. Also too, he requested me to go in and perform a full servicing on the controls. The selectors here are pretty sticky. I can feel what he's referring to, of course. And a lot of us know that when these switches and potentiometers are pretty rough, that they can produce problems with intermittent signal, noise on one or both channels, so forth and so on. In other words, they can cause the type of problem that he's describing. That may not be the case. It may be something unrelated. I'll probably go ahead and do that on camera. I said that I would do that once in a while. I'm not going to do that on every video, but I'll go ahead and do that on this one, get it hooked up to the dim bulb tester. We'll kind of check that out and see how it responds. I'm sure it's going to respond favorably because the customer was using this receiver not that long ago. That said though, we don't want to get lackadaisical and say, well, the customer used it recently, so I'm just going to power it up. You know how that goes. It performed okay for him, but it may not do that for me. It may go into meltdown mode if I don't have it current limited and go through the obligatory process of monitoring, the dim bulb and making sure that this thing isn't trying to run away, and as I say, go into meltdown mode and all that stuff. So I'll do that on camera and I'll kind of talk about it a little bit. I'm not going to go into great detail, but I'll just kind of mention a few things. And if that's looking good, then I'll pipe a signal in and monitor the outputs. Of course, it'll be on a dummy load, and go from there and see what we have. While monitoring it, of course, on an oscilloscope, I'll go through and manipulate all the controls, play with the controls, and see if there's something going on, and particularly that's affecting the channel that he's talking about. So anyways, let me go ahead and get into that. I will be back in just a moment once I get it hooked up to the current limiter, get everything ready to roll. Okay, and here we are, looking down in the top side of the unit, of course, and I want to do that before powering it up. I will typically always pull the cover off, of course, before performing a power up, especially on unknown equipment. And I know this was in use by the customer, and it looks like a pretty clean specimen overall. And if you kind of take a look inside, I'm not going to go into a lot of detail panning around, but you can see everything, at least on the top side here, looks pretty original. Looks good. Doesn't look like anyone's been in here that shouldn't have been in here. Everything looks pretty clean, other than a little bit of dust and not even very much of that. Everything looks good. So I don't have, any nagging suspicions that this thing's going to try to fail catastrophically or whatever the case. So, and I always mention too that as I go into stuff, I start inspecting things in a little bit more detail. Initially, I'll use my magnifier here and go in and really comb through things and take a closer look. And the boards that I end up having to remove, I flip them around, look at the back sides and solder joints, traces, all that stuff, the stuff I talk about all the time. Now I'm going to go ahead and get this powered up on the current limiter. I'll talk about that. So let's go ahead and move into that. Okay, amigos y amigas, the current limiter. Now, what is it? Well, as the name implies, it limits current. And it does that by utilizing the resistivity of the bulb filaments. The bulb filaments obviously are resistive, and as such they limit current. Now, depending on the size of the bulb in terms of wattage, that dictates how much or how little current you're feeding to the device under test. And that's the whole point. On mine, I have 3 different bulbs, bulb wattages, and you see the switches on the side that I could pull in one at a time or in combination, so that I have a little bit more variation. But you can just use a single socket current limiter, just one bulb, and just unscrew that particular bulb and insert another bulb of a different wattage and all that. Just know that the different size bulbs, hence wattages of bulbs, dictate how much current is being fed to a device under test. And when you first power it up, you're going to initially starve it of current, really limit the amount of current, in other words, and incrementally build up and feed it a little bit more and a little bit more until you're confident that, hey, this thing's looking okay. As you're reading the bulb filaments, I say reading, you're monitoring things, and you could tell by the behavior of the bulb filament as to whether or not a device under test is trying to run away. Run away meaning it's trying to pull heavy current so that it can fail. I use and I'm sure I'm not the only one that uses kind of a fire or wildfire analogy in that. If a fire is going to try to run away and go out of control and burn up an entire forest or neighborhood, well, it needs fuel to do that. It needs fuel, it needs oxygen, and if you deny it of that fuel and that oxygen, the materials that it wants to consume and the oxygen it needs, well, then it's going to peter out. It's going to die out. Same thing with the current limiter. You're denying the device under test that is going to fail. It wants to fail. There's something wrong in there. Well, it needs that fuel for its fire. And that current limiter up there, especially if you have the bulbs sized properly, then you're really starving it of the fuel that it needs to go into meltdown mode and fail. And that's very important to understand, and that's why we're doing what we're doing here by powering this device up safely. So in a nutshell, that's what's going on. I hope that's fairly clear. At least it gives you an idea. I'm not going into all the little details, but there's, again, a lot of information out there on that topic, even building current limiters and all that stuff. So we'll just run with that, and I'm going to start out limiting the current pretty heavily, and you'll see that because I'm using a smaller bulb initially, it's really going to limit the current. And when I first power on the device with the bulb switched in, it's going to glow really bright as the big filter capacitors charge up. It's going to glow bright, and depending on the size bulb, once again, it's going to dim down. Now with a smaller bulb that's really going to limit the current, especially on a device under test, a receiver this size, it's going to glow bright and it's going to come down a little bit, but it's not going to go down a lot. But that's normal in this case. But still, you can tell by the character of the bulb, when you're looking at it, the character of the filament, like if it's really trying to surge, and you could tell this thing is just really trying to fail, and it's trying to draw heavy current, and you know, it's kind of surging or flickering or acting funny, well then you know that there's a problem. Okay, but even with a bulb that size, when I bring it in, it's going to still kind of glow bright, but it should stabilize. It should just kind of sit there. Okay, and then as I monitor that for just a few, then I can bring in a larger bulb. It'll dim down a bit more, and that's the normal behavior that you're looking for. Okay, to the point where when you give it enough current, it's doing all right. You know, you're going to hear the relays click in too. Once it has enough current to function properly, you'll hear the click of the relays, and everything's okay. It's not trying to run away. The bulbs that you're pulling in are dimming down. They're staying dim. They're not trying to go bright again. And then eventually, when you get to the appropriately sized bulb that matches up with the device under test, then it'll dim down nice and low, and you'll see a little faint glow of the filament. And that's a good thing. Okay, those are all good things. So I'll leave it at that. Let's go ahead and get this baby powered on. Keep an eye on the small bulb on the left. You see how initially it came up really bright and it did dim down. Now what I'm going to do is I'm going to keep an eye on that just for a minute, and I'll turn off the camera while I do that. When I come back, I'll leave the bulb on like that. I'll just leave it in place, and then we'll kick in another bulb, and you'll see that as I feed it more current, you know, it's going to dim down lower. And as long as this device under test isn't trying to run away and fail, we should be good. And it'll just dim down and it'll stay nice and dim, okay, like I was explaining. So I'm going to monitor this just for a few, and then I will be right back. Alright, so I'm back, and I'm going to click in the next bulb, and notice when I do that, everything's going to dim down there as long as the device under test continues to behave itself. It's doing good so far. And then on my end of things, I'm not going to pan the camera down, but I'm looking at the dial face, and it's very, very dim right now. Obviously the relay hasn't kicked in because this receiver is really starved of current right now. When I pull in the other bulb and feed it more current, you're going to see everything go a lot dimmer, pretty much where it should be for the most part, and you'll probably even hear the relay click in. So I'm going to, you know, after I pull in that next bulb, shortly after that we probably will get a relay click. The dial face lamps are going to glow brighter and all that, so we're giving it more current, obviously. So let's go ahead and do that. Okay, you heard that click, and you can see how dim everything is now. So I'm going to monitor that for a bit, off camera of course, and if everything's looking good, and I'm sure it will, you know, be just fine, then I'm going to get this hooked up to the dummy load, get my signal piped in, get it hooked up to the scope, and we'll start going through the controls and see how the controls are behaving as I'm moving them around, and we'll really pay attention to the right channel and see what we have there, and if the controls have any influence over that, which doesn't matter because, like I already said, I'm still going to go through and provide full servicing of the controls. You know, even if I have to suss out another problem elsewhere, I still want to get all those controls serviced, because at this point in the receiver's life, they need to be serviced, especially because those selector switches that I pointed out earlier, they're all sticky and all that crap. So we'll go ahead and do that anyways. So let me go ahead and monitor things for a while, and I'll be right back with this thing all hooked up and ready to assess the right channel. Okay, so the receiver did fine on the current limiter at idle. Not a single hiccup. So before I pipe in a signal and start monitoring things on the scope and messing with controls and all that jazz, as I already explained, I'm just kind of checking things out in terms of bias, DC balance. In the interest of time, I already went through the DC balance, And I'll explain what that involved. It's very straightforward. I'm not going to demonstrate it and go into adjusting things and demonstrate how to adjust the DC balance. Very straightforward. I'll just kind of point it out real quick and it'll be pretty evident. So you just want to hook up your meter, your DMM, one probe to ground, the other to post 19, which is right here. The board is clearly marked, but you can see where my pointer is sitting. And if I step over here to the other side, I believe you can see this over here. Let me look in the back of the camera. Yeah, this trim pot over here on the board is what you adjust to achieve as close to 0 volts as possible. And I already did that, like I said, in the interest of time. The DC balance responded well. It was low in the first place, but I dropped it down a little bit more, and there you go. So let me talk a little bit about the bias. So as you can see, I'm hooked up to a couple meters. Here's the probes here for the right channel board, amp board, the left channel amp board. You can see I have a couple probes here going off to the meters. And if I zoom in just a little bit, you know, the boards are obviously identical. They're mirror images of one another. So this is the trim pot, the VR that you adjust to set the bias. You're going to want to set it at right around 25 millivolts. And as far as where the probes hook up on these posts here, it's 14 and 16, posts 14 and 16. And like I said, the top of the board here is clearly marked. These posts are clearly marked, so not a big deal there. So anyways, let me go ahead and move on. So as I was setting the bias, I noticed that the right channel, the problem channel, was dropping in and out. I would set the bias and at around 25 millivolts, you know, each channel. And I noticed the right channel, I would set it and then it would drop out. When it would come back in, the voltage would vary a bit. It would come back in at 1 voltage, drop back out, come back in at another voltage. So in other words, very unstable, kind of all over the map. And the left channel over here, it's what, I'm around 22 millivolts right now. You know, it kind of, it goes up and down, you know, up and down, and kind of fluctuates a little bit here and there, but for the most part it's holding. So anyways, one of the things too that I'll mention is when I noticed the bias issue on the right channel with my non-conductive pointer, I was just kind of probing around, flexing the board a little bit, tapping at a few components, kind of moving them just slightly, because you want to be careful when you're doing that. But I was just checking for connection issues, in other words, just giving things a little flex, you know, a little poke and all that to see if any of these posts up here might be loose or something or whatever. And that didn't seem to influence anything. I even was, of course, pressing lightly on the VR to see if there was a bad connection or whatever the case. Those are things you want to check because that can happen. A connection issue can cause unstable bias and your bias to drop in and out. So anyways, everything looks okay on the board as far as that goes. And another thing too, I was checking the controls to see if any of these had any influence over the bias dropping in and out, or when it would drop out, to see if when I would manipulate the controls, if the bias would come back up or whatever. And it didn't seem like that was the case. There was a couple times where I thought maybe there was some influence there, but it might have just been the timing. So I'm not really sure. You know, it seemed like it could have just been a coincidence. So I'm just leaving it at that for now because I haven't really had time to analyze things in depth for a lengthier period of time, which is what I'm going to have to do. You know what? Real quick, let me pan back over here. You see the bias kind of came back in over there, but see it's kind of unstable. Well, see, now it's kind of bouncing around. It's jumping all over the place. Yeah. So there you go. You kind of witness that. So there's something else going on, and I believe it's isolated to the amplifier board. And I'll explain why that is in a minute, or kind of demonstrate why I think that is. So let's go ahead and get to that. Okay, we're looking at the signal now on both channels. You'll see the yellow trace the right channel, blue traces the left channel. You'll see the right channel misbehaving, hopefully. Now that I'm rolling video, let's hope that it doesn't decide to behave. I doubt it. But just keep an eye on that yellow trace. And I'm sure that any moment now it'll start getting naughty. Funny how that works. You know, when the camera's, there it goes, good. And the relay kicked out too, so. Yeah, but I was going to say, it's funny how that works. You'll have the camera off and it'll be going nuts, and right when you turn it on and start. Yeah, you can see it getting a little bouncy too. But right when you roll the, there we go. You back the volume down just a little bit. Yeah, there we go. So it's doing a lot of that, and like I said, the controls need to be done, but there's something going on the main amp board. And I say main amp board because off camera I isolated the main amp and the preamp, and I wasn't getting that behavior on the preamp. It's on the main amp board is the long and short of it. So I am going to check one more time just to be sure. In fact, I'll go ahead and do that in just a minute and report back. But yeah, anyways, you can see what's going on the right channel. So let me go ahead and just leave it there. I'm going to go back to the preamp, make double sure that everything's clean and stable on the preamp end of things, and then go from there. Okay, and we're looking at both channels of the preamp out, and I've been monitoring things for a while. Everything is stable. I'm still going to keep monitoring these channels for a while longer, off and on. I want to be double, triple sure that there's not a single hiccup in that preamp section, that it is in fact isolated to the main amp board on the right channel. So that's where I am at this moment. Like I said, I'm almost certain that the main amp board is going to need some work. Probably bad transistors, I would say. Another thing I want to mention along those lines is these amp boards are populated with some of those problematic transistors that are kind of on the poop list, as I say. Namely the two SX1010s and some others as well. So I need to go through and just, again, suss things out. So that being said, I'm gonna leave this video here. I have a strategy, a plan of attack. That's the main thing. I wanted to see for myself what was going on, and I wanted to isolate the preamp from the main amp and all that. And I pretty much know where I need to go from here. So there is going to be a part 2 video, unless the customer pulls the plug and says, forget it, but I don't think that's the case here. So anyways, I'm going to get with the customer because I need to talk to him about some things. Send him a link to this video, of course. Talk to him about a few things, because one thing I'm going to mention is that if I need to go in and do some work on the right main amp board, it's going to be wise to do the same on the other amp board as well. In fact, the best thing to do is just to pretty much overhaul both of the amp boards, because again, there's those problematic transistors that don't age particularly well and are known to get leaky and noisy and all that stuff, and that's pretty much what I think is going on in this case on that right channel board. It'll be a good idea to just go through and spend a little more time on the board, and as I always do, go through and check the components on these boards and see what's out of tolerance, what isn't, and all that. I'm going to be doing that on the right channel board anyway, so that would be my advice to the customer. I'm going to talk to him about that. I'm not going to recommend a full recapping right now of this unit because I just don't have the time to do it right now, and I don't think he wants to go to that level, at least at this point. But at the very least, I think we should redo these amp boards. So anyways, when I come back, in part 2, that's what I'm going to be doing. I'm going to be sussing out the problematic board, and then probably reworking both of these amp boards and bringing them back to spec and cleaning them up and all that good stuff. So I'm going to leave it here for now, guys, and as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, you all take care.
This is a poor man's shoe production.